Okay, good evening, ladies and gentlemen. This is Professor David J. Delosreyes. Okay, the date for today is September 5, 2024, and the time is, what time is it? 9 p.m. here in Los Angeles, California. Okay, my topic for this evening will be a continuation of my long video format topic, analytic geometry. We are on the second part of the so-called topic parabola. Okay, let's proceed. The subject matter for tonight will be analytic geometry, lesson number 13. And the title of the topic, specifically speaking, is it should be the study of a parabola, okay, with vertex at the origin. Axis is horizontal, and it will either opens to the left or to the right. For tonight, I'll be discussing two parabolas, so we will expedite a little bit. Because the last two lessons, I discussed the parabola that opens upward. Next lesson is the parabola that opens downward. So for tonight, I will be discussing a parabola that is either it will open to the right or opens to the left, and the axis is horizontal. This is just a continuation of the previous two lessons. We just interchanged the variables in the equations and also with the figure. So for figure number 1 for tonight, this will be our third parabola actually. It's a parabola with vertex at 0, 0. Axis is horizontal, okay, and it opens to the right. So if we try to bring out the specification of the figure, it will still be the same as from the previous lessons, except that the so-called orientation will be different. Because the orientation now will be, the axis will be along the x-axis, and it opens to the right for the first one. The second one, it opens to the left. Okay. Let's try to bring out the specific points on the parabola. It's still the same as from the previous two lessons. The vertex of the parabola is at the origin. The coordinates will be 0, 0. This will be the focus, and this is straight line here. And it happens that for this type of parabola, it should be a vertical line, not instead of the so-called horizontal line. So this is the directrix, and the equation of this one is actually x equal to a negative p. It is a straight line, okay, vertically erected, and the equation is actually x is equal to negative p. So this will be the directrix, this is the focus. And as I have said from the previous lesson, that the locus or path of a point which is equidistant from a fixed point in a fixed line at any point on the graph will be a parabola. Okay? So the coordinates of this focus here will be P and 0. Because the distance from vertex to the focus is actually, the abscissa is P. So if we try to bring out the specification of the coordinates, it will be P0. Okay? So the distance from vertex to focus is P. From vertex to the directrix, the fixed line, is also P. And the length of the lateral recta is just like this one. Lateral recta, it could be a Latin term, latera recta, it's synonymous to rectum, okay, our anus. It's the opening of our anus. And the total length of the latera recta is 4p. So from focus to this latera recta first is 2p, the next one is 2p, so the total length of the latera recta or the latus rectum is 2p. meaning how wide is the lateral recta for a parabola, it will be 4p. Because in the application of this one, we need to know the distances of this lateral recta. It depends on what type of problem we will be solving involving parabola. Okay, so the specification of the points on the parabola, okay, in which the axis is horizontal, open to the right, are these. And the equation of this one is actually y squared is equal to 4px. So for figure number 1, 4 to 9, the corresponding equation will be, it is y squared is equal to 4px. It's the reverse of the previous two lessons, because our equation is actually symmetrical with respect to the x-axis. For one value of x, okay, there will be two values of y. Okay, if this is x now, if we specify the value of x to be this, we place it here. And if we try to compute for the value of y, it will be a quadratic equation. So it will either be a plus or minus. Okay. So as the point moves, there will be two values of x. Okay. The negative value and the positive value. That's why, as I have said a while ago, the axis of the parabola is axis. The axis is actually symmetrical with respect to the axis. So the axis is actually horizontal. For any value of x, there will be two values of y. 1, 2, 1, 2, 1, 2. Negative, negative, negative. These are all positive. Okay? So this will be the required equation. And if we try to read this type of parabola, okay, we will automatically place that the vertex is at the location 0, 0, meaning at the origin. Axis is horizontal, meaning there will be two values of x or y for one value of x. That's the meaning of this. And opens to the right. Opens to the right. Have you noticed this type of parabola here? Have you seen an airplane A380? The big one? You don't notice it that the nose or the front portion of the, what you call this airplane A380, or the Boeing airplanes, right? It resembles a parabola. I think the engineers have followed the, what you call this, equation of the parabola and bringing out the shape of this one to be something like this. So one application of a parabola is actually the shape of the face of an airplane, airplane A380 or any airplane that is Boeing, something like that. Okay, that's in actual reality problem. Okay, figure number 2. Figure number 2 is just the same as the opposite of figure number 1. It is just that the parabola is actually opens to the left. Okay, so for the specification of the points correspondingly in the parabola, it will still be the same. This should be the vertex. Okay, they should be the focus. These are the ends of the lateral recta. This is the focus, right? And this vertical line here is the so-called directrix. And the equation of this directrix, it's a vertical line. It is to the right of the y-axis, so the equation will be x equal to a positive p. Okay, so it's a must that you know how to plot a straight line which are vertical, because those are needed in the so-called giving equation names for the directrix. For the first one, the equation of the directrix is x equal to negative p. It's to the left. For the second one, the equation of the directrix is actually x equal to positive p. It is to the right of the y-axis. That's why it is positive. For the specification, it's still the same. From vertex to focus, the distance is p. And from vertex to directrix, the distance is still p. From focus to one end of the lateral recta is 2p. And from focus to the other end of the lateral recta is 2p. lateral recta is a Latin word, or lateral recta, it's a plural. So the singular thing is the so-called latus rectum. Latus rectum, rectum, it's our anus, right? It's an opening of our anus, something like that. So they are all the same, except that the orientation will be, this will be to the left, and this is to the right. But regarding the equation will be the same, except for this negative sign here. The negative sign, meaning to say that the parabola opens to the left. Okay? Because for this y here to have two values, all values of x should have a negative sign. Okay, negative sign. Because a negative times a negative will become a positive. So if we try to take the square root, a negative and a negative will be positive. So if we try to take the square root, there will be two numbers, up and down. So for the equation of the second figure, this will be the equation. And for it to be correct, all x's should be negative. That's why if there is a value of x, if you specify x to be equal to plus 1, this will be a negative thing. And this y here will become imaginary, meaning to say, for figure number 2, the parabola is non-existent to the right of the y-axis. That's why, like what I said, this parabola opens to the left. Nothing is seen on the right for figure number 2. Okay? Because for this y here to be plus and minus, you specify values of x to be all negative. Supposing we place this one to be x, okay, it's a negative value. So if this is negative times a negative, this will not be positive. So if we try to compute for the value of phi, there will be two values of phi, up and down. For any value of x, that's negative. If we try to compute for the value of phi, there will be two values of phi. Okay? Any negative value. That's why this equation here is having a negative sign. That is y squared is equal to minus 4px. Okay, that's the end of the study of the concept of parabola. So for tonight, the next time around, we will be discussing problems involving parabola. Let's try to see if you can solve problems by just recalling the concepts we have discussed. So in summary, for the parabola, if the parabola is axis vertical, this will be the equation and this will be the graph. Okay? Parabola that opens downward, still the axis is vertical, but this is negative, this will be the equation, and this will be the figure. Right? Our topic for tonight, the last two. The parabola whose axis is actually horizontal, this will be the equation. The first one is this one here. I place it here, the graph will be this. The second one is this. Y squared is equal to minus 4px. Okay, and the graph will be a parabola with vertex at 0, 0, axis horizontal, opens to the left. This is the graph. So like what I said, even though you are dreaming, you should you should recall these equations of parabolas and even the corresponding figure, okay, to the given equations. Okay, good evening from Los Angeles. This is Professor David.